Okay, let's finish this up. Hopefully this won't take as long as the first part did. So we saw one way to solve systems is by graphing. We're not going to do that very often because it takes a long time. We are mostly going to be doing this with one of these algebraic methods, and there are two other ways. One is called, which word I do it in? One is called substitution. Substitution. And one is called, the other one's called elimination. I can tell you when I was a student, I always did elimination and never, or I always did substitution, and now I always do this way if I can. Sometimes one is much easier than the other. I don't know, elimination for me tends to be easier. So we're just going to do an example of each here, and then we're going to talk about maybe how to choose which one to do if you want to decide, if you don't want to just do the same one every time. So here's substitution. So it's kind of easy to do substitution here because this one is solved for y and this one is also solved for y. So basically if y equals this and y equals this, then these two things must be equal to each other. Or you could think about it like if y equals this thing here, let's see, this is y and that's y. So if y equals negative 5/3 x plus 3, I can replace this y here with negative 5/3 x plus 3. You might even say I could substitute negative 5/3 x plus 3 for this y here. So that's what I'm going to do. I'm going to plug this in right here. So I get negative 5/3 x plus 3. That's the, 5/3 x plus 3 equals negative 1/3 x minus 1. And that gives me an equation with just an x in it, which is good because I know how to solve those. You may be thinking, I wish this didn't have fractions in it, and I agree with you, so let's get rid of them. I'm going to multiply everything in this equation on both sides by 3. So 3 times negative 5/3 x is negative 5x. Like 3 times negative 5/3, the 3's cancel out, the negative 5 stays, negative 5x. 3 times 3 is 9. 3 times negative 1/3 is negative 1. So there's a negative x there. And then 3 times negative 1 is negative 3. Now I solve it like I normally would. Maybe add x to both sides. And that would give me negative 4x plus 9 equals negative 3. Subtract 9 from both sides is probably a good next move. Negative 3 minus 9 is negative 12, and I divide both sides by negative 4, and I get x equals 3. And that's great, but that's not the answer, because the answer to this system of equations is an x and a y. It's a set. And I have the x, but I don't have the y. And the way to find the y is to plug this x value back into either one of these equations, and that'll give you the y. So I'm going to plug it into this one, just because I don't care which one you plug it into. Just pick one, plug it in. So I'm going to put a 3 right there where the x is. Y equals negative 1/3 times 3 minus 1. Negative 1/3 times 3 is negative 1. So I get negative 1 minus 1. So y is negative 2. And so my answer is something like 3 negative 2. Or something like, or x equals 3, y equals negative 2. Again, I said I don't particularly care which one of these you use, as long as you have, it's clearly indicated to me which is x and which is y. When you put it in a pair, I always assume the first one is x, which is natural to assume. And this checks out with what we thought before. I think when we solved this before, this is the same system, right? We got 3 negative 2 in the previous video. And doing it here, we got the same answer, 3 negative 2, and that's good. Should work both ways. And so that's called substitution. That's where you like solve an equation for one of the variables and then plug that into the other one. This one was convenient because this was already solved for a variable, so I just plugged this in where I saw the y. This one, it's not solved for a variable, and it's set up in a very specific way where it's actually pretty easy to solve this one using elimination. And here's what you look for elimination. Look for opposite coefficients. Oh boy. Let's write that word over again. Coefficients on X or Y. Either one works. Now I can see here the coefficient of X in both of these is 1. Those are not opposite, those are the same. But if I look at Y, the coefficient of this Y is +1, and the coefficient of this Y is -1. And so that's the situation. There's an opposite coefficients on Y. One's positive, one's negative. And what I can do then is I can add the equations together. This is a little bit funky, but you may have seen this before when you learned this the first time. I can add everything. If this is equal to this, and that's equal to this, then when I add them together, the two sides must add up to the same thing. So I get X plus X, which is 2X. And I get Y plus a negative Y, which is basically Y minus Y, which is 0. So it's plus 0. And then I add 92 and 46, and I get 138. 2X is 138. Divide both sides by 2. X equals 65, 69. Yeah, that's right. And now this is, again, only half the answer, right? It's good to get here, but I got to figure out what Y is. So you just pick either one of these to plug it back into. I picked the bottom one before. I'm going to pick the top one now. So I get 69 minus Y is 46. And 69 minus 23 is 46, right? So Y is 23. Let's see, 20, 60, yeah, that's right. So the answer is something like this, 69 comma 23. Or again, you could write it like this if you really want to. The times when it's going to be important that we do this is when it's not an obvious coordinate pair. Sometimes the systems, the things represent things that aren't X and Y. When we get to word problems, I just want to make sure you know that these things are equivalent. Again, if it's in the coordinate pair, I always assume that this is X and this is Y. So that's the third way. We got graphing, substitution, which is where you replace one thing, you solve for one of the variables, then replace it in the other equation, or elimination, where you add the equations together and one of the variables disappears. Like I said, sometimes these things are set up for one over the other, and sometimes they're not. And sometimes you just have to do whatever is more comfortable for you. So we're going to look at these. What would be the best way to solve these? Well, I don't know. This one, it's hard to know, but I can look at this and I can see that because these numbers don't have a lot of common divisors, if I try and solve this for one of the variables, I'm going to get fractions. So what I would do for this one is I would multiply the top one by 2, and then you can get rid of it. So this one I think was best solved with using elimination. This one I already know one of the variables, so I would substitute -3 for Y down here, and I would get my answer that way. So substitution. Yeah, this works best when one equation is already solved for one of the variables, or would be easy to solve for one of the variables. This one, it's up to you really, to be honest, but like this one, you could solve this bottom one for Y pretty easily. It could be pretty easy to write Y equals 3x plus 4. And then plug that in up here where the Y is. So that would be substitution. Substitution. This one, again, you could solve this pretty easily for X just by subtracting 4Y. So I would probably do substitution here. I mean, honestly, I would do all of these by elimination, and we can talk about how that would work when we get to class. This one, probably, again, either one works here, I think, either. And this one, what's going on down here? Yeah, we're going to talk about this right now. And this one, I don't know. It's up to you. Either, whatever you want to do. So let me do an example. Let me show you why I think elimination, this would be pretty easy. This one here, X plus Y equals -1 would be, this one would be pretty easy to solve for Y. but I still wouldn't do it that way. And let me show you how I would do this one. X plus y is negative. I'll write this one again. That's 1, and then negative 3x minus 2y is 8. So here's what I would do. You can you could solve this for y, but here's what I would do instead. I would multiply this top equation by 3. Multiply by 3. What I mean is multiply both sides of it by 3. And what that would give me is 3x plus 3y equals negative 3. And then if I rewrite this other one below it, negative 3x minus 2y equals 8, you can see now I have opposite coefficients on x, 3x and negative 3x. And like this multiplying by 3 wasn't very difficult. It was a pretty straightforward thing. So now I can add these together. And I get 3x plus negative 3x is 0 x's. 3y plus negative 2y is just 1y. And then negative 3 plus 8 is 5. So y is 5. And like that was, I feel like that was pretty straightforward. The trick is to like figure out what do I multiply one of the equations by to get an opposite coefficient. I could have just as easily multiplied this equation by 2. If I decided to do that, I would get 2x plus 2y is negative 2. And negative 3x minus 2y is 8. And you can see multiplying this one by 2, right, times 2 there, gives me opposite coefficients on y. Then I add those together, I get 2x plus negative 3x is negative 1x. 2y plus negative 2y is 0, and negative x is 6, which means x is negative 6. If I wanted to, I could plug this y equals 5 in. Right, so this is, again, these each give me half the answer. And if I was going to solve this system from scratch, I wouldn't do it both ways. What I would do is I would choose a way, like I chose multiply by 3 first. And I did this and this, and I got y equals 5. Then I would plug this back into one of my original equations to find x. So let's say I plug it into the first one. Then I would say x plus 5 is negative 1. Subtract 5 from both sides, you get x equals negative 6, which is the same answer I got down here. So this here, this is like one method for solving it. You like set it, you like multiply one of the equations, both sides, by a number so that you get opposite coefficients, add the equations together, and the one with the opposite coefficients disappears. Then you get one of the variables, then you plug it back into one of the original equations to find the other one. This is just 2 different ways to do the same thing. If I wanted to do it, start off multiplying by 2 like I did over here, I get x is negative 6. Maybe I'll plug that into the top one as well. That equation was x plus y is negative 1, so I get negative, oops, that's red now. Let's get rid of that, shall we? Go back to black. I would get negative 6 plus y is negative 1. Then I would add 6 to both sides, and I get y equals 5. And so like this is just like another way to do this. I could do it either one of these. I could use either one of these methods to solve this system. I just want it to be clear that this is 2 different ways to do this. Like I said, I would never use elimination twice on the same system. You just use it once, and then it's much easier just to plug this value back in to get your second answer. But conveniently and happily, we got the same answer both times. We got x is negative 6 and y is 5. Or you could, of course, write it like this. So this is the answer. Like I said, there's like kind of it's called a row operation, but like you can multiply or divide if you want to either of these equations by any number, and you know that that's going to give you the same, like that's going to give you another valid equation. Multiplying this one by 3 allowed me to eliminate the x pretty easily. So that's how elimination and substitution work. There's going to be a ton of practice on this moving forward. And we'll do some of that in class. So hope you enjoyed this. Bye.